Good morning, Precalculus scholars. Welcome to day 12 of your e-learning. Today we are going to learn about our last conic section. It is called hyperbola. The best thing I can tell you about hyperbola, it's going to feel a lot like an ellipse until you graph it. I'm going to give you more information than what you need on this first page, and then I'm going to give you just the bare essentials on what you need to do with hyperbolas. So a few things you need to remember about a hyperbola. Hyperbola is a shape when you form that looks like, basically, we're going to change colors here, two parabolas, one right on top of each other. And they can either open up, down, or right, left. I mean, honestly, they could rotate, but we're not going to worry about that. A few things you need to know. Halfway smack dab between the vertices of your parabola is your center. And in the center passes through two asymptotes. And the asymptotes help us draw our parabolas. And if we were doing more time, and probably not doing e-learning, I'd actually even teach you how to do the equations of the asymptotes, but you're going to be more worried about drawing them. So you right now have the three main pieces of information you need to know. You need to know the center, you need to know the vertices, and you need to realize drawing the asymptotes make your hyperbola. Now, the hyperbola has very much a set definition. I'm going to give it to you. You don't have to worry about memorizing it. It's just the set of all points such that the difference of the distances from point P to the two fixed points, the foci, is a constant. Now, something you need to know. They are going to have foci, and they're going to be inside each of your parts of your hyperbola. And you calculate the same as if you were looking for the focus of a parabola, or like the foci of an ellipse. But the nice thing is I'm not making you do that right now, because it's important that you can graph and really work with completing the square. All right, like a parabola, a hyperbola has two standard forms of the equation. All right, the first standard form is the following. It's the quantity x minus h squared all over a squared minus quantity y minus k squared all over b squared is equal to 1. Notice it looks just like almost like an ellipse, and it has a subtraction sign instead of an addition sign. This first one is a hyperbola that opens left, right. All right, so it's going to go to the left or to the right. The thing you need to know, your center of the hyperbola is always going to be HK. Look really familiar. That's going to be your vertices, right? Vertex of a parabola. It's the center of a circle. It's the center of an ellipse. So H and K comes back to help us again. And then our other form is the following. Y minus K squared over A squared minus x minus h squared over b squared is equal to 1. And this is when our parabolas will open up or down. Notice this time a squared does not have to be bigger than b squared. Okay, it does not have to be that way. That only matters for an ellipse. This time a squared is always going to go under the positive term with the hyperbola, and that is always going to be used to find the vertex. Okay. Now, a few things you need to know just in terms, especially those of you going to higher level math than this. Just remember, every hyperbola has two asymptotes. They intersect always at the center. That's what I drew up here in the orange. The midpoint between the two foci, or the two vertices, or we can say the asymptotes intersect at, that is always the center. The points on which the line segments through the foci meet the hyperbola is called the veritas. Isn't that kind of fun? You do not have to remember that name. Okay, and the line segment joining the two vertices is the transverse axis. So again, higher level math, you would have to know those. So guess what? Don't need to know. but helpful if you're going to use future math. Also, this is huge right here. A is the distance from the center to the vertices. And how do I know which direction to go, either up, down, or right, left of my vertices is based off of where it's located. It's always underneath the positive value that is being squared. And so if it's underneath the y, you're going to go up or down. If it's underneath an x, then it's going to go left, right. And c is the distance to the foci. And so here's the cool thing. C always is used to find the foci. And what I mean by that is, notice we use C to solve for it in a parabola and an ellipse. If you were going to do so in a hyperbola, if you were going to be that detailed, C is found by going c squared equals a squared plus b squared. But again, you don't have to memorize that like we normally would, because I'm not asking you not to have to worry about the foci. So when you're doing your homework tonight or this afternoon or this morning when you're working on it, if you're working with it, please remember to follow my directions online. Otherwise, you're going to be trying to do a lot more work than what you're supposed to. All right, so the steps to graph a hyperbola. First thing you have to do is to make sure your equation is in standard form. You need a 1 on the right-hand side, just like with ellipses. You then need to find the center. So I need to know what your h and k values is. Then you have to find the vertices using a. Notice the key from this is you move in the direction of the variable in the numerator. That is the direction of your hyperbola will open. Okay, so I will explain more when we're doing that. Then we also plot the points along your other axis, kind of like a minor axis. We're going to use B. So we're going to use B to do that. And then you draw a box including all these points. And a lot of you will remember this when I work with it. Then the key thing is to draw the asymptotes through the box. And if we really wanted to do the equation of an asymptote, we could use the fact that we can find rise over run real quickly, put it in point slope form. Life would be great. But guess what? I'm not asking you to do that. And then guess what? It says determine the vertices using c squared equals a squared plus b squared. Here's what we're going to do. We're going to do the vertices using A. So we're going to say determine the vertices using A, and then draw your hyperbola. So here's what I mean on this. So here's an equation, and we get 4y squared minus 9x squared is equal to 36. Now, that is not in standard form because it needs to be equal to 1. So what are we going to do first? Well, the first thing you got to do is change it to standard form. So to do that, I have to divide everything by 36. So when we get that, we get y squared over 9 minus x squared over 4 is equal to 1. So this is my standard form of my hyperbola. Now, what does this tell me? Well, first of all, since y squared is the positive term, I know that this is opening up and it's opening down. This also allows me to quickly calculate the center. So the center, because remember, this is my form I'm using here. See if I can, of course, my eraser does not want to work right now when I need it to. We're going to be using the form here, y minus k squared over a squared. Then we got x minus h squared over b squared is equal to 1. So our center, pulling out, since there's nothing with the y and the x squared, is at 0, 0. So I'm graphing my center at 0, 0. Now the next piece of information I need is A. A is always underneath the positive. So a squared is equal to 9, so a is going to be plus or minus 3. Now, it is underneath the y squared, which means I take my a distance and I move in the direction of my y's. So I go up 3. So I go 1, 2, 3, and then I got to go down 3. And those are my 2 vertices. So that's the distance of a. So what are my vertices? We're going to be at 0, 3, and at 0, -3. All right, so I have my vertices. I have my center. Now we're almost to the point of graphing. So to graph, I need to use b. All right, so b squared we know is equal to 4, and b would be plus or minus 2. So you go to your center again, and then you go over b. So I went over 2, and then I have to go the opposite direction 2. And then you're going to make a box. So this is where it's got to be understood. The box has to have the midpoint of each of its sides, either one of the vertices or one of the points I got by b. So the box, I'm going to use red. Oh, let's don't use red here. Let's use black to graph this. Notice it looks like this. So this makes a rectangle. And notice smack dab in the middle of that is your center. Then you're going to draw your asymptotes connect diagonally, going through the center. Don't know why it's doing that, but hey, we'll tap it. Let's go. Why did this go away? Hey, you know what? We just keep going with things. All right, so then we go here. All right, my friends. So we got that in there. Now it's time to draw your hyperbola. Your hyperbola is going to make sure it touches its vertex, and you just draw alongside its asymptotes, just like this. And that is how you draw your hyperbolas. Now, you could find the equations of the ellipses and everything like that, but we're not going to do that. All right, we have 3 more examples. They're all pretty important, but again, we are just looking for the standard form, the vertices, and to graph. So let's look at the next one. Oh, yay! It says find the center and vertices of the hyperbola and then sketch the graph. And notice sketching the graph and finding these things go hand in hand. So first things first, we need to realize we're looking at the form where it's going to be opening left or right. How did I know it's opening left or right? Because x squared is positive. So that's why we're going left or right. We find our center first. And remember, that'd be x minus h squared. This would be y. I don't know why things are not writing here. Y minus k squared. Okay, so that is going to end up being 3, -4. So I go over here to 3, I go down to -4. That is our center. Now we have to calculate the vertices, okay? So the vertices we always use with a. So a squared equals 9, so a is going to be plus or minus 3. Now, since it's opening to the left and right, we go horizontally. So we're going to go here to the right 3, so 1, 2, 3. To the right is going to be vertex. You're going to go to the left 3. So this is your A distance. Why did I go horizontally instead of vertically like on the other page? Is because of what is first in my equation, which is positive. Then you just need to know write those 2 vertices down. So here we go. Our vertices are going to be what? We got over here, we're at 0, actually, let's go the first one here. 0, -4. And our other one, we ended up moving here to 6, -4. So notice if you graph, easy to do. All right, now we have to use b to solve for our box to help it. So b squared is equal to 16. So b we know is going to be plus or minus 4, which means I'm going to go up 4, and I'm going to go down 4, and I'm going to create my box. And let's use orange so it shows up a little bit better. That goes through. Someone always asks me, like, how do I know where to draw the box? Well, notice where the box is going through. It's going through my 2 vertices, and then it's going through the 2 points I use with b. Because remember, I went up b and I went down b, right? To get those 2 values. So then we're going to draw in, my friends. Let's use this one. Our asymptotes, and we go diagonally through the corners of our box. And then we draw our final graph. Let's use navy on this one. Okay, so with this, remember, it has to touch your vertices, and then it just approaches along. the side of your asymptotes, my friends. And so we do the same thing. Notice it doesn't cross the box at all. It just touches at the vertex. And the two values right there are going to be your hyperbolas. Okay. I know I'm going through this fast, but I'm trying to so you don't have to have long notes today. All right, now next thing I'm going to ask you to do is find the standard form of the equation of hyperbola, then find the center of the vertices and sketch the graph. Basically, now we're going to be using completing the square. If it's not where it's supposed to be, I think I'm going to put new batteries in my stuff, guys. What do you think? All right, we'll just try this again. Completing the square is going to be huge. Okay, so on the first one is the key with doing these is to make sure that you again put your variables together. Now I'm using a few things that might be able to help me a little bit, but I'm looking at this and I notice the 9 is in front of y squared is positive and that what's in front of the x squared is negative. And so I'm actually going to put the y's first and group the x's together because of just knowing how it works. So the first thing I'm going to do is I'm going to put my y's together. And then I'm going to put my x's together. And then I'm going to move over my 62 because we still move the constant over. Now this is where it's going to be like ellipses where we take out the coefficient. So it's always 1, a positive 1 in front. So I factor out a 9 between my y's. So I got 9 times the quantity y squared plus 6y plus blank. Now here, this time I have a negative 1 in front. And that means I have to factor that out. So we're going to go minus 1 times the quantity x squared minus 2x, we're going to go plus blank equals a negative 62 plus blank when we're working with it. Now this is the same like when we work with ellipses. You do your completing the square inside the parenthesis. So here we have half of 6. Well, that gives us 3. 3 squared is 9. But then I have to make sure the 9 times 9 happens. And because I'm really adding an 81, I don't know why it's not writing what I'm doing down here. All right, I'm gonna have to pause to make sure my pen's working, friends. Hold on. See if we can get it here. Don't know why that didn't work, but we know we can write an 81 there now, so we're gonna go back with that. Okay, then we do the same thing here. Complete the square with the x's. A negative 2 divided by 2 is a negative 1. A negative 1 squared is a positive 1. But we got to go negative 1 times 1, which gives us, what do we get here? A negative 1. And then we start simplifying it even further, okay? So with this, my friends, we get 9 times the quantity y plus 3 squared minus the quantity x minus 1 squared equals a lovely 18. Then we have to take the time, divide everything by 18, because remember, to be in standard form, it has to equal 1. So we get the now, y plus 3 squared all over 2 minus the quantity x minus 1 squared all over 1 is equal to 1. So here is the standard form of this equation. Makes it pretty easy, actually. Oops, I said over 1, that should be 18. Oh, okay, I did catch it. Those of you who are sitting there thinking brownies caught it. Thank you very much. All right, so with this one, just remember a few important things. You should be able to figure out the center. The center is 1, negative 3, because remember it's y minus k and it's x minus h. So that's why it's 1, negative 3. So I'm going to go down here. 1, negative 3. Where is it? 1, negative 3. Okay, my friends. And then we have to use A to find the vertices. So let's go. A squared is equal to 2. So that means A is going to be plus or minus root 2. Someone goes like, great, so much help. Well, it's actually not that bad, my friends. It's about 1.4 when you're graphing, but right here with this, let's go ahead and find what our vertices are. Now, since A is underneath the y, we're going to go up or down to get our vertices, okay? So with this, I got the square root of 2, and by the way, that's about 1.4. I add it to the y's. So it's going to be -3 plus or minus root 2. So I'm really going right here, and I'm going about, by the way, that's about 1.4-ish. So I go up here, and I go down here, and that's going to be your 2 vertices, okay? Got what we need, the key pieces of information. We're almost there to graph. We have to find B. All right, so B is going to be the square root of 18, which is about plus or minus 3 root 2, which is approximately around about 4.2, okay? So I go to the center, and I have to go horizontally, the opposite way that I did my vertices when I was doing this. So what do we get here? About 4, go over 4, 1, 2, 3, 4-ish, about right here, 1, 2, 3, 4, a little bit past. And then we still, and this is where it's harder, you kind of have to eyeball your box a little bit more. Make sure you make a box between it. Then you draw in your asymptotes. Yeah, this is going to be like crazy wide. And then you just draw in your hyperbola, touching at your vertex and approaching along your asymptotes, and you will get it every single time. All right, almost finished. So let's finish this up, my friends, with one last example. Okay, so with this, my friends, hopefully these are making tons of sense. Let's go ahead, and we're supposed to change it to standard form and then find the vertices and the center so we can graph it. Well, first things first, let's put our stuff together carefully. So again, y is positive here. So I'm going to put my y's together first. So we're going to go 4y squared, and we're going to go minus 24y. We're going to go minus 9x squared minus 72x, and then we're going to add the 72 over. Now remember, we divide by the leading coefficients out of each sets of numbers. So that's what we factor out. So we have a positive 1 when we're doing this. So with the y's, I factor out 4, and I get y squared minus 6y plus blank. Then with the x's, I factor out a -9. Remember, you need the coefficient when you're doing completing the square to be positive. So we go factor out a 9, and we get x squared plus 8x, and we go plus blank equals 72 plus blank with our 2 values. And then we're going to do completing the square. Go to your -6, divide it in half, which is a -3, square it, get 9. 4 times 9, and that is going to be 36. Then we're going to do the same thing with the 8. Divide that in half, which is 4. Square it gives you 16. But I'm really going a -9 times 16, which is a -144. So when we're simplifying this and we start rewriting it in standard form, I get here 4 times the quantity y minus 3 squared minus 9 times the quantity x plus 4 squared, and then 72 plus 36 minus 144 ends up being a -36. So then I divide every single term, because it has to equal 1 to be in standard form, by -36. But notice when I do that, this value becomes negative. This value now becomes positive. So when I finish writing it in standard form, that actually becomes x plus, well, if it's going to let me write it, x plus 4 squared all over 4 minus y minus 3 squared all over 9 equals, I don't know why it's doing this, but hey, you know what? I just go with things, guys. Equals 1. So that is your standard form. You should be able to pull the center out right away. Remember, h goes with x, k goes with y, and we should get the fact the center is at a 4, 3. X is what's under, so we're opening like this, left, right. So that will help me find my vertices. But let's graph our center first. We're at -4, +3. Again, double check me, guys. If I ever make a silly error and you find it, don't worry about, as long as you know process. You guys have always been able to figure that out when I mess up, and I still trust you to do the same thing now. Okay, so now we're going to find our vertices. Okay, remember the vertices are using with A. So A squared is always underneath the +1. So that's 4. So A is going to be ±2. And it moves horizontally because it opens left or right. So we go to our center and we go right to get a vertex, and we go left to get the vertex. And so my two vertices are going to end up being -6, 3 and -2, 3. All right, so now you have all the key pieces of info you need. Now the only thing left is we have to solve for B so we can graph it. All right, so B squared we know is 9, so B, you're going to go ±3. So I got to go up 3. Remember, I got to go distance of B, and I got to go down 3. Now, using B to do that, I've now created my box. Now let's put in your asymptotes diagonally through the corners of your box and through the center. So those would be your asymptotes, and then we just put in your parabola. And I'm going to use purple because it's my favorite color. And remember, it touches the vertex. It goes to the right, going along my asymptotes, touching the vertex, and it goes to the left. So I hope this helps you guys when we're working with this. I know this is a little bit harder, but don't worry. On block day, we're going to step back. We're going to do a quick, this is how you know the difference between different conics, and then we just practice again all 4. So thank you guys for listening. Take good notes. Remember, they need to be submitted with in a separate file, but also when you submit your homework.